let's talk about the distributive property and like terms. So the distributive property, there's actually multiple kind of versions of the distributive property. But the distributive property of multiplication is that multiplication times a sum is the same thing as adding the result of multiplication by each term of the sum. In algebraic notation, A times the quantity B plus C is A times B plus A times C, or if the multiplication is on the other side, quantity of A plus B times C is A times C plus B times C. So doesn't matter which side the multiplication is on, although you'll most often see the multiplication out front of the addition. And then note these properties work in both directions. So if you have the multiplication by the sum, you can turn it into the sum of multiplication, or you can go the other direction. If you have two things, the sum of two things that both have that matching factor, then you can rewrite it as that factor times the sum of the other parts. This also works with exponents with multiplication and division. So the power of a product is the same as multiplying the power of each factor. So you'll see that in the laws of exponents. So generally, distribution happens going down one level. It doesn't skip levels. So if you have a power of a sum, you can't just apply that power to each term of the sum. And that's also under laws of exponents, as well as squaring binomials. But mostly what we're focusing on here is the distributive property of multiplication. So practicing this, 2 times x plus 3 is 2 times x plus 2 times 3. I like to just write kind of arrows to remind myself that I'm doing that multiplication times each of those things. The number of steps you write out, you can probably go straight to the 2x plus 6, write out as many intermediate steps as you need to, but don't feel like you have to write out more than what you feel like you need. So the next time we have the sum 1 plus x in the parentheses being multiplied by square root of 1 plus x. So you want to think the square root of 1 plus x is just, it's one thing, and it's being multiplied by the sum of 1 and x. So it's being distributed and being multiplied by the 1 and the x. So that's going to be 1 times square root of 1 plus x, and then plus x times square root of 1 plus x. Or again, you could go straight to the final answer. When we have 1 times things, it doesn't do anything, so it's just square root of 1 plus x. It does do something, it doesn't change the quantity. So square root of 1 plus x square root 1 plus x would be the result there. And then we have negative x minus 12. So you could think of this negative, it's a -1 being multiplied by the x minus 12. So that gets distributed and it's negative x plus 12. Really, if you think of that, then it would be plus -1 if there was anything in front of it. So it is still like a subtraction if it's in with multiple terms. So like terms, terms again are things that are being added together, or subtraction, thinking of that as adding the opposite. Like terms are terms that are the same other than a numerical factor. The numerical factor is then called the coefficient of the term. So for example, 3x and 5x, so the only difference is the 3 and the 5. 4xy squared z and 7xy squared z, they both have the xy squared z, the only difference is the 4 and the 7. 6 times 2 to the x and 11 times 2 to the x, and you have the 2 to the x, the 6 and the 11 are different. Square root of 2 and 4 square root of 2, both have the square root of 2, the only difference is the 4 and an unwritten 1. 2 ln x and 5 ln x, they both have the ln x, and then just the 2 and the 5 are different. So those would all be like terms, and like terms can be combined. So the way you can combine like terms, it's really applying the distributive property in reverse. So 3x plus 5x, 3 times x plus 5 times x, then you can turn into 3 plus 5 times x, or 8x. Typically, we don't write that intermediate step. We just know that we can add the coefficients of those like terms, and then the rest of the like terms stays as is. So you probably didn't even realize you were using the distributive property in reverse when you're doing that, but that's what's happening. All right, so some practice, kind of putting all of these together, the distributing and the combining like terms. So we have 8x cubed minus 2x squared plus 6x minus 2, all in parentheses, plus 3x to the fourth minus 2x cubed plus x squared plus x. These parentheses aren't really doing anything. There's nothing next to the parentheses that needs to be distributed. We have that plus, so the minus would need to be distributed. It would be plus and negative, but the plus doesn't do anything. So what I need to do here is just look for like terms. So 8x cubed, there's no like term. Negative 2x squared, there's a x squared, so that'd be minus x squared. Then 6x, there's an x. And I lied back there, there is another x cubed. That would be 7x. Minus 2 certainly has no like terms. The 3x fourth has no like terms, but we do have that minus 2x cubed. So it's actually going to be 8 minus 2 is 6. In standard form, typically we would do the highest power first. So this would be 3x to the fourth plus 6x cubed. Since it doesn't have anything in front of it when it's the first term, then when you move it around, it's plus minus x squared plus 7x minus 2, going in decreasing order of the powers of x. But combine like terms, I like to mark the terms as I'm using them. That helps me keep track, and as you saw there, catch that I had missed one of them that needed to be combined. So best practice, mark things off as you use them. This next one, we have 3x to the fourth minus 4x cubed plus 6x squared minus 1. Those parentheses aren't doing anything. There's nothing next to those parentheses in front of them. After them, there's a minus. So they're just grouping addition and subtraction with other addition and subtraction. So I'm just going to write those out without the parentheses. But then the minus, if we think of that as plus -1 times each of those terms, subtraction has to apply and basically switch the sign on each term that it's being used with. So this would be, so the -1 out front. So minus 2x to the fourth, but then plus 8x squared plus 6x minus 5. All right, so I have x to the fourth and minus 3x to the fourth and then minus 2x to the fourth. So we have 1x to the fourth and then -4x cubed. There's not another x cubed, so minus 4x cubed. And then we have plus 6x squared and plus 8x squared, so a total plus 14x squared. And then we have a 6x plus 6x. And then there's a -1 and a -5 combined to get a -6. All right, and last example here, we have, again, the 3x to the fourth minus 4x cubed in parentheses. If I change the -2 stuff to a plus -2, the only thing around that parentheses is pluses, so those parentheses aren't doing anything other than grouping, but it's not a grouping we need to keep. Then the -2 gets distributed, so that becomes minus 16x squared plus 12x. And there aren't any like terms to combine here. So that's the final answer there. So that's distributive property and like terms.